About 78% of the Earth's atmosphere contains dinitrogen gas. It is also present in Earth's crust as sodium nitrate, Chile saltpetre, and potassium nitrate, Indian saltpetre. The 11th most abundant element, phosphorus, exists as phosphate, fluorapatite, and hydroxyapatite. The other elements, arsenic, antimony, bismuth, are present as sulfides and are not very abundant. Nitrogen, the principal gas of atmosphere, 78% by volume, is separated industrially from liquid air by fractional distillation. Pure nitrogen gas can be obtained by the thermal decomposition of sodium azide about 575 Kelvin. 2Na-N3 is reduced to Na plus N2. It can be obtained by oxidizing ammonia using bromine water. NH3 ammonia plus bromine water gives NH4Br plus nitrogen gas. Nitrogen gas is rather inert. Terrestrial nitrogen contains 14.5% and 0.4% of nitrogen 14 and 15 respectively. The latter is used for isotopic labeling. The chemically inert character of nitrogen is largely due to high bonding energy of the molecules, 225 Cal per mole. Interestingly, the triply bonded species is notable for its less reactivity in comparison with other isoelectronic triply bonded systems such as triple bond C, CO, XC, XNC, C triple bond C, C triple bond N. These groups act as donor, whereas dinitrogen cannot. However, it can form complexes with metal like carbon monoxide to a less extent. The only reaction of nitrogen at room temperature is with lithium, forming Li3N, which other elements nitrogen combines only at elevated temperatures. Group 2 metals and TH forms ionic nitrites. Direct reaction with hydrogen gives ammonia. This reaction is favored by high pressures and at optimum temperature in presence of ion catalyst. This reaction is the basis of Haber's process for the synthesis of ammonia. Nitrogen plus hydrogen gives ammonia. This with oxygen, nitrogen produces nitrous oxide at high temperatures. Even at 3473 Kelvin, nitrous oxide yield is only 4.4%. Nitrogen is used for manufacture of ammonia, nitric acid, and calcium cyanamide. Liquid nitrogen is used for producing low temperature required in cryosurgery and so in biological preservation. Ammonia is formed by the hydrolysis of urea, NH2SONH2 plus H2O gives NH3 plus CO2. Ammonia is used in the laboratory by heating ammonium salt with a base, NH4 plus OH plus gives ammonia plus water. Ammonium chloride plus calcium oxide gives calcium chloride plus ammonia plus water. It can be prepared by heating metal nitrates such as magnesium nitrate with water. Magnesium nitrate with water gives magnesium hydroxide plus ammonia. Ammonia is a pungent smelling gas and is lighter than air. It is readily liquefied by about 9 atmospheric pressure. The liquid boils at 38.4 degrees Celsius and freezes at -77 degrees Celsius. Liquid ammonia resembles water in its physical properties. It is highly associated through strong hydrogen bonding. Ammonia is extremely soluble in water. At low temperatures, two soluble hydrate, ammonia, water, and 2NH3H2O are isolated. It is in these molecules, ammonia and water are linked by hydrogen bonds. In aqueous solutions, also ammonia may be hydrated in similar manner, and we call the same as ammonia NH3H2O. The action of heat. Above 500 degrees Celsius, ammonia decomposes into its elements. Decomposition may be accelerated by metallic catalysts such as like nickel, iron, etc. Almost complete dissociation occurs on continuous sparkling. Ammonia does not burn in air. but burns freely in free oxygen with a yellowish film to give nitrogen and steam. In the presence of catalysts like platinum, it burns to produce nitric oxide. This process is used for the manufacture of nitric acid and is known as Ostwald's process. Ammonia acts as a reducing agent. It reduces the metal oxides to metal when passed over heated metallic oxide. And treated with acids, it forms ammonium salts. This reaction shows the affinity of ammonia for proton in greater than that of water. Ammonia reacts with chlorine and chlorides to give ammonium chloride as final product. With excess of chlorine, ammonia reacts with nitrogen to give nitrogen chloride, trichloride, an explosive substance. With strong electropositive metals such as sodium, ammonia forms amides, while it forms nitrates with metals like magnesium. Ammonia reacts with metallic salts to give metal hydroxides or forming complexes in case of copper. Ammonia forms ammoniated compounds by ion dipole attraction. In this, negative ends of ammonia dipole is attracted to Ca2 plus ion. Ammonia molecule is pyramidal in shape. NH bond distance is 1.016 Armstrong and H bond distance is 1.645 Armstrong with a bond angle of 107 degree. The structure of ammonia may be regarded as a tetrahedral with one lone pair of electrons in one tetrahedral position, means it has a pyramidal shape.